Given cos y is equal to x times cos of L plus y, to prove that dy by dx is cos square of L plus y divided by sin L. First of all, we will rewrite the given equation as cos of y divided by cos of L plus y is equal to x. Now differentiating with respect to x on both sides, we get, it is like in the left hand side, it is like u by v. So it is, I have to first write down the denominator, which is cos of L plus y, differentiate the numerator. If I differentiate cos of y, it is minus sin y, minus of numerator, which is cos of y. And if I differentiate the denominator, it is minus sin of L plus y whole thing divided by cos square of L plus y times dy by dx is equal to 1. So now this can be rewritten as minus sin y cos of L plus y, minus or minus, it becomes plus cos y sin of L plus y times dy by dx. I am cross multiplying this cos square of L plus y with this one. So to the right hand side, it will become now cos square of L plus y. Now we have a trigonometric identity, which is sine of A minus B is equal to sine A cos B minus of cos A sine B. So applying that trigonometric identity in the left hand side of this above equation, we will have, see here it is like sine A cos B. So that means here I will say here A is L plus y and B is y. So you will have now, it is like sine of A cos B minus cos B, minus cos A sine B. So I can write the left hand side now as sine of A minus B, that is L plus y minus y times dy by dx is equal to cos square of L plus y, which means sine of L times dy by dx will be cos square of L plus y. That means our dy by dx will be cos square of L plus y divided by sin L. That is what we are supposed to prove, cos square of L plus y by sin L. If y is equal to x to the power of sin x plus cos x to the power of x, find dy by dx. So let u is equal to x to the power of sin x. Taking logarithm on both sides, we get log u is equal to sin x times log of x. Now differentiating with respect to x on both sides, we get 1 by u du by dx will be keeping sin x, differentiating log x, we get 1 by x plus keeping log x, differentiating sin x, we get cos x. That means our du by dx will be u times sin x by x plus logarithm of x times cos of x, which means our du by dx will be, what is u? It is x to the power of sin x and times sin x by x plus logarithm of x times cos x. So we get our du by dx. Now let us consider the second term as v. Let v is equal to cos x to the power of x, cos x to the power of x. Taking logarithm on both sides again, we get log v is equal to x times logarithm of cos of x. That means our differentiating both sides with respect to x, we get 1 by v dv by dx will be keeping x and then differentiating log of cos x, we get 1 by cos of x. Again, differentiating cos x with respect to x, we get minus sin x plus keeping logarithm of cos x, differentiating x with respect to x, we get 1, which means our dv by dx will be v times minus x sin x divided by cos of x plus logarithm of cos of x. Now substituting the value of v, which is cos x to the power of x, and then multiplying individually these two terms. See, in the first term, cos x is there in the denominator, so I can put power minus 1, and then minus of x sin x will be there. Then again, cos x to the power of x outside into log of cos x. So plus cos x to the power of x times logarithm of cos of x. So therefore, since our y is now, if you consider this, this means y is actually u plus v. That means dy by dx will be du by dx plus dv by dx. So on that basis, our dy by dx will be now du by dx. What is that? Here it is. X, you may notice x is there in the denominator for the first term. So I can write it as x to the power of sin x minus 1 times, what is that other term? Sin x, and then x to the power of sin x multiplied by log x cos x, logarithm of x and then cos x. Then dv by dx, which is plus cos of x to the power of x minus 1. Since there is a minus, I will change this sign to minus. And I will put that x here, sin x plus cos of x to the power of x logarithm of cos of x. Since they didn't ask us to prove to any particular term, we can stop it here. So that is the dy by dx for the given function. If x equal to a times t plus sin t, y equal to a times 1 minus cos t, find d2y by dx square. So first of all, we will rewrite this x as x is equal to at plus a times sine t, which means our dx by dt will be a plus a times derivative of sine t is cos t. So we can rewrite it as a times 1 plus cos t. Then let us rewrite y, which is a minus a times cos t. So dy by dt will be differentiating a constant is 0 minus a times differentiating cos t will be minus sine t. So this becomes a times sine t. Therefore, dy by dx, that is the first derivative, will be dy by dt divided by dx by dt, which will be a times sine t divided by a times 1 plus cos t. This a and a gets cancelled. We get sine t divided by 1 plus cos t. Now sine t can be written using our trigonometric identity as 2 times sine t by 2 times cos t by 2 divided by, similarly 1 plus cos t can be written as 2 times cos square of t by 2. So this 2 and 2 gets cancelled and 1 cos t by 2 gets cancelled. We get the sine t by 2 divided by cos of t by 2. So therefore, dy by dx is nothing but tan of t by 2. Now that means our d2y, that is second derivative by dx squared, will be, if I differentiate tan x, it is secant square x. So here it will be secant square of t by 2. But we need to differentiate the t by 2 again, which we will get 1 by 2, then multiplied by dt by dx, because we have to differentiate it with respect to x. So now dt by dx, we already found out that. Let us substitute it. 1 by 2 times secant square of t by 2 and dt by dx. We have dx by dt as, sorry, here it is dt. So we have dx by dt as a times 1 plus cos t. We need dt by dx, that means it is the reciprocal of this. So we will write it as 1 divided by a times 1 plus cos t. Again, 1 divided by 2a secant square of t by 2, and then 1 divided by 1 plus cos t can again be written as 2 times cos square of t by 2. So we will get now d2y by dx square, that is second derivative, as 1 by 4a. Here we have secant square of t by 2. And if I take this cos square t by 2 to the numerator, it becomes the secant square of t by 2 again. So ultimately we get secant to the power of t by 2 divided by 4a. That will be the second derivative for this particular function. Here it is given as if y is equal to square root of tan x plus under root tan x plus under root tan x and so on, it goes up to infinity, then show that dy by dx is secant square x divided by 2y minus 1. First of all, we can rewrite this function y as root of tan x. Again, if you look into this, it is nothing but y only. So plus y I can write, which means our y square is nothing but tan x plus y. Now differentiating with respect to x on both sides, we get, if I differentiate y square, it is 2y times dy by dx. And if I differentiate tan x, it is secant square of x. And if I differentiate y, it is dy by dx. Which means I can take this dy by dx everything to one side. So you will have 2y minus 1 times dy by dx is equal to secant square of x, which means our dy by dx is secant square of x divided by 2y minus 1. That is what we need to prove. Find the derivative of sine x square with respect to x square. So first of all, let us assume u equal to sine of x square, which means our du by dx is cos of x square times, again I need to differentiate x square, we get 2x. So ultimately we can write it as 2x times cos of x square. Then let v is equal to x square, which means our dv by dx is 2x. So if I want derivative of sine x square with respect to x square, it means that to find du by dv. Du by dv is nothing but du by dx divided by dv by dx. Du by dx we already found out, it is 2x times cos of x square, and dv by dx is nothing but 2 times x. So the result is cos x square. If y is equal to x times e to the power of sine x, then find dy by dx. It's a simple product rule. So we can directly write dy by dx equal to x. Then differentiating e power sine x will give us e power sine x times, and I have to differentiate now sine x, which will give me cos x, plus e to the power of sine x. Differentiating x will give me 1. So that means here the common term is e power sine x. So you get x cos x plus 1. That will be the result for this. Find dy by dx if y is equal to e to the power of x square tan x. So straight away we can find out dy by dx. It will be e power x square tan x. So you will write that as it is first, because a derivative of e power x is e power x. Next step is you go one side, one step inside, that is this x square tan x. We need to differentiate that using uv method. So it will be x square, and if I differentiate tan x, it is secant square of x plus tan x, and if I differentiate x square, it is 2x. So this will be rewritten as e to the power of x square tan x. And then we may notice like x is common, we can take it outside. So we will have x secant square of x plus 2 times tan x. So that will be the result for this. In this question, dy by dx, when x is equal to cosecant inverse of 1 plus t square by 2t, and y is equal to tan inverse of 3t minus t cube divided by 1 minus of 3t square. So we will start with assuming first, let t is equal to tan theta. That means our x will become now cosecant inverse of 1 plus tan square theta divided by 2 tan theta. And whatever is inside this bracket, that is nothing but cosecant times 2 theta, or cosecant of 2 theta, means this will be cosecant inverse of cosecant of 2 theta. So this will become now cosecant inverse of cosecant of 2 theta will be nothing but 2 times theta. Similarly, now y is equal to tan inverse of 3 times tan theta minus tan cube theta divided by 1 minus of 3 tan square theta. Now, whatever is inside this brackets, it is nothing but tan 3 theta based on trigonometric identities. So this will become now tan inverse of tan 3 theta. So tan inverse of tan 3 theta is nothing but 3 theta. Therefore, our dx by d theta will be differentiating 2 theta with respect to theta will give you 2. Similarly, dy by d theta will be 3. So therefore, our dy by dx will be 3 by 2. That is the result of this particular problem.